is actually such a useful thing. It's um, for so many things, for so many processes. This is one more way in which it's useful. So it says how many grams of silver are produced when a current of 3.4 amps is passed through a 1 molar solution of silver nitrate for 314 minutes. This in the lecture outlines is what I call electron bookkeeping, and it could also be called electron stoichiometry, where stoichiometry just means unit conversion factors. And the key to this is that the Faraday constant, which is our F, capital F, says there are 96,485 coulombs per 1 mole of electrons. And coulombs is a unit of charge, and we've already seen that coulombs times volts equals joules. We're going to have a different set here, and that is what's called an amp, or an ampere. An ampere is a measure of current. Let me ask you a question. Have you heard of amps or amperes before? And if so, what can you tell me about an amp? For example, how many amps or milliamps does it take to run your phone? Or recharge your phone, I should say.
2,000 to 8,000.
About 1,000, did you say?
Yeah.
Yeah. Right. And let me, I'll be right back. So I just went to get this AC adapter, and it's for a little motor I use here. And it says right on it, AC adapter, it says volts, and then it says, for me, it's 700 milliamps, as the output, and it takes in 150 milliamps. And these are, on most power adapters, more information than we really need. But basically, amps are, so current is a flow of electrons, measure of current, which is a flow of electrons. And if you've ever heard that it's not the voltage that kills you, it's the amps, that's what we're talking about. It's actually the charge that runs through you. Hopefully it doesn't run through you, though. Now, the relationship we need is that 1 amp equals 1 coulomb times 1 second. And that's what the C stands for, coulomb times 1 second. Such that if we know the time and the amps, hold on, did I mess up this relationship too? Sorry. 1 amp times 1 second equals 1 coulomb. Does that look right? Yes. Amps times equals coulombs, yep. If we know the amps and the time in seconds, which of course we're going to have to convert this to seconds, this number of minutes up here, we can get the coulombs of charge. We can use the Faraday constant to convert coulombs into moles of electrons. And from there, we will need, we'll be able to get moles of silver and grams of silver. And in fact, when the first power system was installed in the United States, the person who installed it to deliver electricity to a person's house actually made silver to keep track of how much electricity he was delivering to a person's home, or in many people's homes. It was Thomas Edison. So it's got some historical significance too. But so here's our process. So we're going to take our amps times our seconds and then convert them into coulombs. So we have 3.4 amps. And the symbol for amps is just going to be capital A. And I need my number of seconds. So I'm going to take my 314 minutes. Convert my 314 minutes into seconds. So there's 1 minute equals 60 seconds. Yeah. So I get 18,840 seconds. Times 3.4 amps. Sorry, I went to make a different symbol there. That's just a scribble out. So 64,056 when I multiply these two together. And these are amp seconds, which are also, so amp seconds are coulombs. There we go. And from now on, I'd like to put this into a picket fence like I like to do. 64,056 coulombs. 96,485 coulombs is 1 mole of electrons. And now if I'm going to do the next step, which is a mole to mole ratio, I need to know what the half reaction is here. I'm starting with silver ion. I am going to silver solid. My half reaction will be silver plus 1 electron goes to silver solid. And the half reaction I'm talking about will always be one of the reactions on our SRP table. Here's the silver reaction. We don't need the potential this time. All we need is that there's 1 electron here for every 1 mole of silver produced. So this relationship comes from the balanced half reaction. And now, if I look at my units, my coulombs cancel, my moles of electrons cancel. I now have units of moles of silver. And now I'm back to my molar mass. 107.9 grams of silver is 1 mole of silver. And now I'm going to multiply this out. 64,056 divided by 96,485 times 1 over 1, but then just times 107.9. I get 71.6 grams of silver. And one more question, but any questions about this one?